In this video, we're going to learn about the OSI model. And if you've dealt with networking for any period of time, you've probably had some exposure to the OSI model. Now, a lot of people don't really love to deal with the OSI model or think about it, but really once you kind of demystify and explain what the OSI model means and get used to working with it, you'll find it really is an essential tool to kind of talk about networking protocols. So all the OSI model really is kind of like a logical representation of how our devices on a network can communicate with each other. And the job of the model is to break down all of the functions that have to get performed by these components that are connected to the network, and then it breaks them down into simplified layers. So let's start out with the very basics. What does OSI stand for? What is the OSI model? Well, it stands for Open System Interconnect Model. And the model includes 7 layers. And what I want to actually add in here is a little bit of an additional layer that I sort of think at the top of the OSI model. Right, so here we see the application, presentation, session, and kind of on down the line towards the physical, right? And that's the actual physical media, like a copper wire or a fiber optic cable. I like to put at the top of the model one additional layer. And I call this layer simply the user layer, right? At the top of my model here, that's where the user resides. So as the information is flowing up through the OSI model, it's getting closer to my user actually seeing and utilizing that data. So now that we have our user at the top of the OSI model, let's look at the layer below that, the application layer. And this is a really simple layer. This is what the user is going to use. This is what the user is going to see, right? This is some application like Outlook for email, right? And so this is what the user themselves will actually interact with and utilize to receive this data. The next layer is the presentation layer. The presentation and session layers are actually pretty closely linked to each other. Think of these as the things that my operating system needs to do to communicate with some other operating system. For example, I could have Windows running on my machine and I may be establishing a session with another Windows machine. That's what the presentation and session layer do. And honestly, in this video, we're not super concerned with these top 3 layers, application, presentation, and session. These are kind of like the things that are happening within my computer. And we're not so worried about that from a networking perspective. So we don't spend a lot of time on application, presentation, and session layers. So for these 2 layers, let's just call the presentation layer my operating system. We'll call the session layer, this is how my operating system talks to other machines. And now we get into the layers that we're more concerned with when it comes to networking. The transport, network, data link, and physical layers. So the transport layer involves ports and protocols, things like FTP, SSH, HTTP. Those are all different transport layer protocols. And what they govern is how is my data actually moved from point A to point B? Is it going to be reliable? If so, we're talking about TCP. Is it going to be unreliable? If so, we're talking about UDP. And we have these different protocols that basically do things differently. Right? Different types of traffic have different needs. So, for example, let's talk about an unreliable type of traffic. Let's say we're streaming video through Netflix. Well, we don't need to guarantee the reliable delivery of that data. Right? Let's say that a packet is dropped or lost. Well, we're not going to go back and retransmit that packet because at that point it's too late. right? The time has already come and gone for that packet. And so at this point, we don't need reliable delivery of data. So we're going to go with an unreliable layer 4 protocol, right? And that's suitable for certain types of data. However, for other types of data, that might not be suitable. We may need to ensure that every last bit of data that gets transmitted is received. And that's where we're going to use TCP, the reliable delivery of data. And TCP involves significantly more overhead. With TCP, the two nodes that are communicating with each other are going to use tools like checksums to ensure that everything that the sender has sent is actually received by the receiver. And so this involves more overhead and more verification, and therefore it's a little bit less efficient. But there's certain protocols that we want to guarantee that level of delivery. And we'll see this expressed in all sorts of different ports, like SSH, port 22, FTP, port 23. There's a wide variety of well-defined port numbers, and you can also utilize custom port numbers for your own applications. The next layer we'll take a look at is the network layer. This is layer 3. And this is the layer where things like IP addresses and routers reside. So every device on a network has a unique identifier called an IP address. And we may send packets to things like a default gateway, which is commonly a router. And as we work our way through this course, you'll learn a lot more about IP routing, layer 3 traffic, and the actual functions that a router performs. But that's what we're talking about when we talk about layer 3, is IP addresses and routers. Layer 2 is our data link layer, and that layer is commonly associated with Ethernet. So at the data link layer, we're talking about things like Ethernet, about our Ethernet switches, about protocols like ARP, CDP, and we're talking about our local area network, right? The ability to interconnect devices with a switch that are on the same network. Now the final layer, the lowest layer on our OSI model, is the physical layer. And this is the physical stuff, right? It's things like cables. If you have like a microwave wireless transmitter, that's the physical layer. You know, if you have a fiber optic cable, or if you just simply have an Ethernet cord connecting your computer to a switch, that's the physical layer. So if something happens at the physical layer, we're typically talking about like a cable that's been cut, or some other kind of actual physical component failure. Those are the things that create issues at the physical layer. Okay, so now that we've defined the 7 layers and given you a really basic understanding of what is occurring at each layer, let's talk about some of the failures and some of the terminology that is used to associate failures with these 7 layers. And we're going to work our way from the bottom up, because if I was troubleshooting an actual network, that's what I would do. If I have a network problem, I'm going to start by eliminating the physical layer as a potential issue. And honestly, more often than not, that's where you're going to find the problem. So, what sorts of problems can occur at the physical layer? Well, at the physical layer, we're talking about something physical happening, like somebody has unplugged the wrong cable, or somebody has accidentally cut a cable that wasn't supposed to be cut. Or maybe if we're talking about wireless, it's common to see things like interference, or even with Ethernet, that's why that cabling is shielded, right? Because other sorts of electrical devices and things like that can interfere with our cables. So if we're having a layer 1 problem, that means something's wrong at a physical level. So what sort of failures can actually occur at this data link layer? Well, we have a few listed here, and let's kind of work our way through them. Now, in modern switches, we will almost always have a VLAN associated with a port on a switch. Right? So you're going to plug a device into a switch, and that device will be associated with a certain VLAN. We're going to have a video on VLANs coming up shortly. But essentially, here's how it works. If one virtual machine is in VLAN 10, let's say, and another virtual machine is in VLAN 20, they won't be able to communicate with each other over layer 2. It's a way to kind of break my switch up into segments and make it almost feel like multiple switches. Right? There's certain machines that we don't want to have them communicate over the switch. I'd like to force their traffic through a firewall or something like that. That's what we accomplish with a VLAN. So if we've improperly configured a VLAN, or if we've configured a port in the wrong mode, those are data link layer type issues. We can also have broadcast traffic on a layer 2 network. The most common form of broadcast traffic is ARP. And this is where one device is trying to discover the MAC address of another device. And if I have loops in my topology, that's going to result in something called the broadcast storm, where broadcast traffic just goes around and around and around infinitely from one switch to another until it brings our network to a screeching halt. We'll learn about spanning tree protocol in an upcoming video, and that'll help us to ensure that these loops do not exist in our layer 2 network. So those are some layer 2 type problems. Right? And just a quick reminder, the address at layer 2 is the MAC address. Now this MAC address, or media access control address, is hard coded into our network interface cards. So whether we're talking about a virtual machine or a physical machine, there is a unique MAC address hard coded into that device. Now, how about the network layer? What sorts of problems can occur there? Well, the most common problem is a duplicate IP address. Right? Maybe I've got two virtual machines or physical machines or whatever that are on the same network and have been configured with the identical IP address. That's not going to work. Right? Every machine on a network has to have a unique identifier. The IP address has to be unique. And so if we have IP conflicts, that's going to be a layer 3 problem. Or if we have a misconfigured router, maybe routing entries missing from a routing table. Problems at the router level, those are layer 3 issues. The next layer we'll talk about is the transport layer. And honestly, you're probably not going to run into a whole lot of issues here, right? At the transport layer, we don't often see a whole lot of misconfiguration or problems that occur. As a matter of fact, I'm struggling to come up with a great example of a layer 4 problem that I've ever had to fix. You basically, as a networking person, you're not going to have to mess around a whole lot with layer 4. And this kind of is the same for layers 5, 6, and 7. Right? If you're a programmer, if you're an application designer, if you're in one of those roles, then yeah, layers 4 through 7 are really important to you. But from our perspective as networking people, we're very highly focused on layers 1 through 3. Those are the layers that are really critical from a networking perspective, and they're very important to understand NSX and network virtualization as well. So that's the area that we'll focus from here on out moving forward in this class.